Hello, I was watching a debate recently. I think it was on MC Toon's channel, and I got an idea for adding a feature to my skywatching app, and it ultimately turned into what will be this video here. I forget exactly the reason why I was trying to do this, but I was thinking of mapping out all of the stars that were visible to any given observation point. This would have to be at night, obviously. And so let's say I'm standing somewhere in Cape Town, South Africa, and I can see stars around me. So what I did was I added a mode to my app that I developed, and the stars that are currently visible are going to appear as big red dots. The white dots are stars that have not appeared above the observer's local horizon. And if I change the time, you'll see that as these stars approach and come up over the horizon, like this is going to be the head of Taurus, the head of the bull. And as they come up above the horizon, they will slowly turn red. And then if I scrub around, when they have appeared but they're not currently above the horizon, they turn back. They still remain red, but they become smaller dots. And the point of this was I was trying to come up with a visual aid to show which stars never appear above somebody's horizon for any given location. And so basically, if you're in Cape Town and you're looking north, you'll never ever see Polaris. And of course, you can measure the distance to the North Pole from where you are, divide that distance in miles by 69 point some miles per degree to confirm that you are in fact so many degrees south of the North Pole. And the same could be said, let's say, if you go north, for example. Somebody who's this far north will never ever see these stars that appear in the southern hemisphere. So I was trying to figure out how I could visually show, for example, that this part here is in daylight and this part is in shadow based on where the sun currently is. And contrast that with the observer in the northern hemisphere up here somewhere. They are inside the circle, but right now, because the sun and the moon are south of the equator, those appear outside of the horizon line circles relative to where that object is relative to its GP. And at one point, I was trying to figure out how I could go about painting the area. So if you use something like Microsoft Paint, you can do a flood fill. And so if you flood fill outside here, it'll keep this part not filled in. Or if you flood fill inside here, it'll stop at this border. I was trying to figure out how to do that. And I didn't want the computer to spend too much time flood filling, especially if I wanted to do animations. And so the idea that I came up with was rather to use contour lines around each of those objects. So the yellow dot that you see here is where the sun happens to be at that time. The green dot represents the observer, and the blue dot represents the moon. And of course, all of these other dots that you see happen to be the stars. So I was playing around with different locations and different times, and I noticed a rather interesting pattern. So just for reference, let's say you're back at Cape Town. Each of these circles that you see happen to be a difference of 10 degrees in your zenith angle. So wherever you are and you look straight up, your zenith angle is 0. And if you look 10 degrees from your zenith, then you're going to be at this circle here. Another 10 degrees, so a 20-degree zenith angle would be this circle here. So at this time, for this location, this star happens to be at a 20-degree zenith angle. And then, of course, this star over here happens to be at a 30-degree zenith angle, etc. What becomes really interesting is that there are certain situations where the flat Earth model just simply does not work. Now, I happened to watch Simon Dan's video this morning, who included a clip from Bob Nodell, I believe it was, and he said the best map that flat earthers can produce happens to be the azimuthal equidistant map that you see here. So let's just run with this for a minute and say that the azimuthal equidistant map is the correct one. If the Earth was flat, then we would expect that every object radiating out from equal distances from the observer would be at an equal zenith angle. But that just really isn't the case, because if you look off to the east, there will be some stars like this one that will come up above your horizon, even though on a flat Earth, the distance towards it is much further than the distance towards stars in the northern hemisphere that you can't see at all. So there was one case in particular that I noticed that I think flat earthers would have a hard time to be able to answer. So let me just go back to a geolocation that matches a hiking trail as seen right here like this in Cape Town. So the hiking trail is right about here. That's the geo-coordinate. You can go and track that down if you want, but this would be the view from that hiking trail looking east. So what I've done was I said, okay, so if you are here, where would be the sun at sunrise at a distance farther than the distance to the stars directly to the north? So here you are standing and you're looking at the sunrise towards the east, and just for reference, that's about where the sunrise would be. And so the sun would clearly be over Australia, and if we give it a little bit more time so that it's clearly above it, like over here, the distance here on a flat map is much further than the distance to the North Pole. In fact, the North Pole would be right around here somewhere. So I figured, just to be fair to the flat Earth, I didn't choose a location that was more in the middle of Australia. I decided to choose something that was a little bit closer to the west coast. So I went digging through the map for Australia and I found this place here. So this is a place you could go to and find out for yourself. And more than that, being at a latitude of 23.1522 degrees south, the sun should go directly overhead at 4 o'clock in the morning, UTC plus 2 hours. But obviously the sun won't quite be above the horizon in Cape Town at that point, so we just have to wait a couple more hours. And then the sun will pass over the meridian of Linden, and that's the time that I'm going to go for. So I'm going to go for 6:16 a.m. local South Africa time, which would put it somewhere around this time right about here. So according to Stellarium, on December 13th, this is my time by the way, on December 13th at 6:16 a.m., the sun should appear like this from the east, and it should be morning. And if I come back and do the same thing again at Linden, so here I am at Linden, the sun should be pretty much directly overhead. So I'll let flat earthers try to determine the distance on their flat Earth map. Between those 2 points, you have those geo-coordinates, and how would that compare to the North Pole not being visible? And I almost forgot to include this part. So as I've shown, I can model what it looks like if the Earth was a globe, and I projected the zenith angles for anywhere on the Earth transformed to the AE map, or if I assume that the Earth is flat and I draw concentric circles like this, if I export that data to a KML file, I can see what each of those looks like in Google Earth. So this would be where the sun is over Linden over here. I'm pretty close. I got a few seconds off, and then I come over here to that trail in Cape Town, South Africa. And while I was at it, I also included the moon. But I wasn't really interested in the moon at this point. You can see that along the surface of the Earth, they all form concentric circles like this. But it is, of course, dependent on wrapping around the globe and staying on the surface of the Earth. But what would happen if I took the flat Earth data points and I tried to model it onto the globe? And so as you can see, it looks really weird, to say the least. And the spacing between each of these are not consistent. And when it gets to the South Pole, it actually does this. That's it for now. If you made it this far and you like the video, I would appreciate the thumbs up, the subscribe, all of that other stuff. And I will see you again in another video soon enough. So bye for now.